All right, so I want to show you some things about optimization. This is a fairly challenging lesson typically. I mean, almost like related rates. Just so you know, before you start that it's typically a challenge, but I'm going to try my best to make it as doable as possible and so that you get the big picture and that it makes sense. So really what we want to do is we want to optimize, meaning you want to find the maximum or the minimum of an application type problem. Okay? And there are some really good steps to this. So, and then tomorrow we'll take a look at, well, tomorrow being Friday, we'll do a little sort of a box exploratory activity that really helps with this as well. Okay. So, example one, look at this little shade thing. Oh, actually, let me back up. I need to tell you the steps. Kind of like, again, with related rates, it's kind of hard enough that we need some nice steps to be able to solve these. So, step number one, we want to read the problem carefully. You're like, good, but we got to read the problem carefully. Number two, we want to draw a diagram, if possible. A lot of times you can. Number three, it's really important that you come up with an equation or a function. Usually it's a function, right? A function that describes the relationship. And then fourth, we want to use substitution if necessary so that you really can write the function in terms of just one variable. Because a lot of times you're going to have two variables, but it's really going to be easy if you have, just y equals, some function of x, or it doesn't have to be y and x, but at least just one variable. Okay. Then, because you're looking for the max or the min, we're going to use our strategy of finding the first derivative and saying, hey, wherever the first derivative equals 0, that's probably going to be a high point or a low point. So that's going to be a key, use of, finding your key way to find your max and your min. And then number 6, use those critical numbers to determine the max or min. And then we would answer all the questions and interpret the solution and see if it actually makes sense for the problem that we're solving. All right. All right, let's go ahead. Wow, I got my little shade thing going on every one of these slides. Okay, so example one. Let's try to figure out two numbers whose difference is 100 and whose product is an absolute minimum. So it's the lowest product we could think of with two numbers that have a difference of 100. So we don't know what our numbers are. So let's let x equal one of our numbers, and then I think it would make sense that the other number would be x plus 100, and it would be 100, they'd have a difference of 100. So you could do it that way, or some people would rather say x and then x minus 100. Amazing, it works both ways. So you can try both ways and see which one you like better. I stick with the positive one just so that, obviously set plus, plus instead of minus. The product of those two numbers is x times x plus 100, and that's my function. So my function is p of x, and then the question is, well, now I just need to figure out what's the minimum value of this function, and that would be my minimum product. So we find the critical numbers, which are found by finding the first derivative. So 2x plus 100, and then we just set that equal to 0, and we find our critical number is negative 50. And it turns out this function has a minimum whenever one of the numbers is negative 50. And if one of the numbers is negative 50, then of course, the other number is, negative 50 plus 100. Whoa, got it. All right. So then one of them is, ay caramba. So one of them is negative 50, and then I think you already know the other one, what that would be, is 50. Okay. I think I got it down. All right, so negative 50 plus 100 is 50. So these are the two numbers, and when you multiply them together, you get the absolute lowest product you could ever get, and so that would be a product of, multiplying them together, that would be a product of negative 2,500. That's the minimum product. So it depends on what they're asking for. If they say find the two numbers, well, your numbers are right here. They're negative 50 and 50. Yeah. Now, what's happening graphically? So we go to graph it, graph the function, and you would see if you graph this function that it would look like this, and that the lowest point, that's your minimum, right there. So your lowest point would have a vertex there. Well, I shouldn't say a vertex, because they're not going to all be parabolic, but this one is. So this one has a minimum at -50, and then the y-coordinate is cool because the y-coordinate is always that max value or that min value. So it is -2500. So very cool. All right, let's try another one. Next one, we want to minimize the perimeter. So what's the smallest perimeter possible for a rectangle whose area is 16 inches squared? And then go ahead and figure out the dimensions. Okay. So we go ahead and draw a picture. So here's a rectangle. It has dimensions, length and width. And we know the area, so we're going to utilize that information. So we're going to say the area would be length times width. And we're going to go ahead and plug in the 16 there. And so we would have, we could isolate the L if we wanted to. But actually, I should back up and say that since we're talking about perimeter, we know that we would start with perimeter equals 2 times the length plus 2 times the width. And then it would be a matter of, gosh, we need to figure out a way to get this into one variable and utilize the information given. So again, the information is, that 16 equals LW. If we could just isolate the L and say that L equals 16 over W, then we could come back over to this perimeter equation and we could plug in 16 over W for the L. Then we'd have nothing but W's, as far as the function goes. So P would equal 32 over W plus 2W, so that'd be great. So I'm going to go to the next slide with that because that's the function that we would actually want to minimize. So we would take this function, and I'll need to show some work here. So I would want to find the critical numbers. So I probably will set this up so it's a little bit better to apply the power rule. So hopefully this guy will cooperate with me. So P equals, let's say 32W to the -1 would be better. And then let's find the derivatives. P prime equals -32W to the -2 plus 2. And then let's let's set this equal to 0. So we'd have 0 equals -32 divided by W squared up and down the bottom. Plus, this guy's really temperamental. I think it's just testing my patience, this little guy. Yeah, well. Okay, so plus 2, and then, isolate the W squared, so maybe subtract 2, however you want to do this, obviously. Okay, my little screen, let me get rid of it. Alright, so we got -2W squared. Wow, am I going to make it through this deal? Okay. Alright, so W squared equals 16. So W equals, plus and minus 4. And it only makes sense, to have 4 as a width. So we're going to say that width would equal 4. And then if we wanted to, figure out, hey, what's the length going to be? Well, we would go back and we would look at what we had before. We had length equals 16 over W. So we can utilize that information. And so we have, sorry, I lost my mind for a second. So we have a little string here, plus again. So yeah, L equals 16 over W. Okay, so L equals 16, and of course that'd be over 4, and so the length is actually 4 as well. So the dimensions, if they want the dimensions, it's 4 by 4. If they want to say, hey, what is that minimum perimeter? Then that perimeter, would be adding up all the sides. So that would be 4 for, that way, or just twice the length plus twice the width. All right. So, and then the graphical on this, very similar. We would just graph the function, and we would notice that the lowest spot here would be at 4 and then comma 16. So it's really cool how how this works out. Hopefully you can see that's the function I have plugged in right there. 32 over x plus 2x. Okay. I do have another example, but it's the box one, and we're going to go ahead and explore that one together on Friday. So bring your, bring your books so we can be productive on Thursday working out some problems. Okay.